Hello, in this video we will be exploring how to find the length of the longest substring of non-repeated characters in the input string and also compute the time complexity and space complexity of the solution that we will be building in JavaScript. Let's first try to understand what the problem statement is. Given an input string here, let's say ABC, BC, BB, we have to find longest length of non-repeating characters. So what I mean by that is, let's say you have A here. You see A has not repeated so far in the string. So all good. You say 1. Then you go to B here. B is also not repeated so far. So you say like 2 is the length. Then you go to C here. And you see C has also not been repeated so far. So you can say the length is 3 so far. And then you go to the next one, and here you can see A has already been repeated, and that's why we just stop here and we can say like this is the length of 3. And if I try to find more in the list that we have of non-repeating characters, so now we broke here. Now we can just start all over again and try to see. We saw A, B and C again, and we can say that this can also be the longest substring because after this we have B, and then if you see B and B, they are repeating, so you can't really say that you have the highest length there. That's why it's either this or this, and that translates to the highest value of 3 of the longest non-repeating length of the substring that we have. And to solve this problem, we will be using a 2-pointer approach. So we will have one pointer called as start pointer and another pointer called as end pointer, and we will traverse the entire length of the string to find the highest non-repeating character length. And to do this, we will be using a data structure. So I have a set here which I will be using to build my logic around this algorithm. So we can start and say that we have iteration 1. So we just start from here in the loop, and we will iterate this end pointer until it reaches here. So we will say like until the end pointer reaches the end of this string that we have, keep going forward in the loop. And in the first iteration, what we will say is start is at 0 and end is also at 0, and max is going to be initialized to 0, and this max is going to be a result that we return at the end once we find the highest number. And what we will do now is we will check at this end pointer whatever character we have is there in the string set or not. So this set is going to store characters from this string uniquely, and we will just check, hey, is the set having this element? If it doesn't have that element, we will put that element in the set, and we will increment our end pointer by 1. So this is like the new end pointer, and what will basically happen is now instead of the end pointer being at 0th location, it will be now here after we do this. And the new max is going to be the max between the existing max, which was 0, and the size of this set that we have, which is 1 right now. So we will say max is 1. So from 0 it became 1 at the end of the first iteration. Now we will go to iteration 2. Now we had start still at 0, the end was 1, and the max was also 1. At this position we have B pointing to this end pointer. So in the second iteration we will say whatever is at this pointer, which is B, is there in the set or not. And we will say if it is not there in the set, we just put it in the set. So we will say put B in the set and increment the end pointer again. So now from 1 the end pointer will become 2, which will basically means that it will now go to this one, and a max will be the maximum between the existing max value, which was 1, and the size of the set. Size of the set is 2, so our new max is going to be 2 now. And we just keep iterating. We reach iteration 3 now. Our start stays at 0, it has not changed. Our new end is now going to be 2 from the previous one so far, and a max we have as 2 also. Now we will see what is at this pointer, which is C. We will say, hey, is C there in the set that we have or not? If it is not there in the set, we will just put it in the set. And once you put it in the set, we also increment our end pointer. So now end pointer becomes 3, and max becomes the highest between our current max, which was 2, and the size of the set. The size of the set now becomes 3, so that's the higher value. So we will say this is 3, and again we move this pointer that we had to the next position by incrementing it to +1. So 0, 1, 2, 3, which is this position, and we just move forward. So we now at iteration 4, we still have our start as 0, end is 3 currently, and our max is 3 right now. Now at this position, we tweak the logic a bit as we encounter our first repeating characters. So we will say now, hey, is this element there in the set or not, which we have been doing for the past 3 iterations that we had. And as you can see, A is already there in our set that we have. So now instead of incrementing and, what we will do is we will say remove the element from the set. So it will now go from the set that we had, and this element was basically originally in our set here, and this was the start pointer. So we will basically say something like whatever element was there at this position, which was our starting point in the non-repeating substring that we had, which translates into something like, if this is, let's say, string s of start, which is here, that we have removed from the set we had. And then what we do is we increment our start pointer now. So because the repeated chain broke of non-repeating characters, what I mean to say is we had like unique elements up to this point. A was unique, B was unique, C was unique, they were not there in the set, and now the chain broke. So now we have to start all over again, and now we will say a new start is going to be, instead of here, the new start will be here. And again we will try to see whether we have non-repeating characters or not. So we start over, and end remains as it is, we don't touch end. Start changes and we increment a start here. So this is a new start, and the max that we had, we don't change that, we just keep as it is in this case when you find it in the set that you have been building through the iterations that we covered so far. And if you keep doing this repeatedly, you will end up with the highest number as 3. So max is going to be 3 at the end of your iteration once your end pointer reaches here, and that's pretty much going to be our solution using these 2 pointers that we have. And now what we will do is we will just translate this into code, and it will look something like this. So we will say let start is equal to 0, which was this pointer that we had earlier, and we will say end is equal to 0. So both pointers at the start pointed to here, and we will say max is also 0 at the start, and we will be using a set data structure to keep track of our unique characters. And at the end, we're just going to return our max, which is going to be this value. And we said that we will keep doing this until we reach the end of the string. So that basically translates to while end is less than s dot length, you keep doing the logic that we just now discussed. And we saw that if the element doesn't exist in this set, we do something, otherwise we do something else when it exists. That is, we remove it from the set in the fourth iteration. That's what we did. So we say s of end dot has. So what I mean to say is like set dot has s of end. We check if it is there in the set or not. If it is there, we do something. Otherwise, we do other operation. And what we said is, if it is not there in the set, we just add that element in the set. We increment our end pointer, and we check what our new max is. So mat dot max comma set dot size. That's the size of this set that we keep building as we iterate. And so this condition that is here stayed true with us until we reach the third iteration. And then at the fourth iteration, in this example, we saw that we started seeing like not repeating. So like we had a here, and at the fourth iteration we started seeing a. So the chain broke. And in that case, what we did was we said set dot delete s of start, which was a. Now a no longer exists in the set because we just removed it from the set, and our start pointer also increased, which was basically this at position 0. Now it became at position 1. And that's pretty much the core of the functionality that we built. And yeah, that's pretty much it. And in terms of time complexity, I can say that because this string in worst case can go up to n, the time complexity will be big O of n, because we will traverse through each element, each character in the string based on this end pointer condition that we have. So we will keep traversing until we have end, which is this pointer, less than the length of this entire string that we receive. And that's why the time complexity is big O of n, wherein n will be the length of the string that we have. Because in worst case, you might iterate through the entire length of the string and not find non-repeating length at all. And in terms of space complexity, it will be order of 1. Reason being, we are using a set and we can have only limited number of alphabets in the string, and that's why the set memory will be fixed. So you either put the unique element in the set or you delete it from the set. It's not going to be you're going to store the same element multiple times in the same set. So it's either at one point in time it will always be unique in the set. That's the main reason we used a data structure to maintain this uniqueness, which will give us a space complexity of order of 1, which is constant, because we can have limited alphabets in the string that we receive. And that's pretty much it. Thank you for watching. Please like and subscribe. Bye.